Welcome students. Today we are going to discuss about the feedback topologies. Analysis of four amplifiers: voltage amplifier, current amplifier, transconductance and transresistance amplifier. So here in voltage amplifier, the first one is a voltage amplifier. It is represented by the letter AV. AV can be represented by V naught by VI. So V naught is the output voltage and VI is the input voltage. The output you have to write like this, the other name of this amplifier. So output side you have to write, if it is a voltage you have to write voltage, or otherwise if it is a current you have to write current. And then input side, if it is a voltage you have to write the word series. If input is current means you have to write the word shunt. Then the same one have to copy here itself, series. Then the reverse case, if output is voltage you have to be represented by the word shunt. So this is the way you have to give the name of voltage amplifier. And AVEF is nothing but voltage amplifier with gate. It can be represented by V naught by Vs. So the diagram, coming to the diagram, the red color portion of the circuit diagram indicates the amplifier diagram, and the blue color lines are telling the feedback diagrams. So start with your here voltage amplifier, both your input as well as output is a voltage source. So we have to give the word Vs, and voltage means you have to give the RS resistor immediately series with that one. If it is a current source, you have to give the parallel term. Then a diamond shape symbol indicates the dependent current source. So it is V naught is dependent. This can be written by seeing this formula. AV equal to V naught by VI. So from this you have to write V naught equal to AV into VI. This is the way how to give the name for the dependent source. And then both the name, that is your input side is a series connection, output side is a shunt connection. So this is the series connection and this is the way called as a shunt connection. Then if it is output is voltage means you have to make it this one as open. If it is a current source, output will be I naught means you have to short it this one. And then this series connection, you have to introduce the diamond shape symbol. If it is the polarity symbols is plus minus means you have to fill plus minus. If it is an arrow mark, you have to fill the arrow mark. And then the name has to give from this left hand side, that is voltage. If input is voltage means you have to give the letter VF. If input is current means you have to give the term IF equal to beta. This term is constant because it is a feedback factor. Beta into output side. Output is V naught means you have to give the word V naught. Output is current means I naught. Then there will be three concepts. One is to calculate the gain. Second and third is calculation of input and output impedance. The first step for calculation of gain by seeing the formula, you have to write the formula. Then second step, you have to by seeing the feedback, you have to get the equation. Then step 3, you have to apply the KVL equation to here. So input side, you have to apply the KVL equation. So 3 voltages will be involving. Assume this RS voltage is to be negligible. Therefore, we are getting the equation like this. Then after substitution, AVF equal to V naught by Vs. Just substitute the Vs equation here. Vs will be equal to Vi plus Vf. So here we have the Vf answers. Vf is nothing but beta into V naught. V naught will be equal to AV into Vi. So likewise you have to substitute each and everything. So after finally substituting, we are getting V naught by Vi into 1 plus beta AV. Therefore V naught by Vi already we derived, it is called a AV. Likewise it is a calculation of the voltage gain. The next one is calculation of input impedance. So RIF. RI is the constant formula. RIF is the depend on the amplifier, it will be varies. So RI will be equal to Vi by Ii. RIF is nothing but if input is voltage source means you have to give Vs. If input is a current source means Vi by Is. Yeah. Then for last equation we are getting the equation Vs will be equal to Vi into 1 plus beta AV. Just substitute that directly itself. So within 1 minute we can get the answer of Ri. Vi by Ia is nothing but Ri into 1 plus beta into AV. The next one is output impedance. Similarly, you have to calculate for R0 and R0F. Previously RIF. Likewise, you have to derive for R0 and ROF. ROF is a constant formula V0 by I0. That's why the constant formulas I represented in a square box. Clear? And R0 will be going to be differ. If output is a V0 means, so numerator will get disturbed. If output is a current means, the denominator have to disturb. So the current voltage flowing across the R0 resistor. So there will be two voltages flowing on the R0 branch. One end is V0, another end is VAV into VI. So subtract both the terms. Then there will be a simple substitution VI equal to minus VF. While getting this equation, you are getting in step 2, previously calculation of gain. In that, you have to make short circuit that voltage equal to 0. Because we are finding out output impedance, therefore, you are making the input side as input source will be 0. So finally, then VF, we already know VF will be equal to beta into V naught. After substituting, we are getting the RYF equal to R naught by 1 plus AV into B. So after completing these three things, you have to draw the equivalent diagram. The same equivalent diagram what we have drawn for the amplifier in the previous steps, right? The same thing. The difference is here you have to introduce RIF, ROF, and VI dash. Previously it is VI, now it is will be VI dash. So this is the thing. This diagram is nothing but combination of both feedback as well as amplifier diagram. Initially, while starting the derivation, we drawn two things separately, amplifier part and feedback diagram, but now it is a combined thing. So this is the first amplifier. The second one is nothing but your analysis of current amplifier. The same methodology you have to follow. Analysis of current amplifier. So see here, output is your current, so the current word I have to written. Input is current, so it called shunt. The same shunt has to be copied here, and then output is current, so it is called series. So another name of current amplifier is shunt series. Then see here, input will be the shunt connection, output will be the series connection. Then you have to write the diagram. If it is a current source, the immediate resistor must be connected in parallel. Previous case we have voltage source, it connected in series. Now it is in parallel, and this name you have to be getting by this cross multiplication, AI into II. Then you are getting this equation. And see here, if it is a arrow mark, you have to give the arrow mark here. And then if your input is your current source, means you have to give the word IF. Beta into output is a current source, so also it is called as a beta into I naught. As usual, three steps: calculation of gain from by looking the formula, then by looking the feedback and apply the KCL now. Previous case we are applying the KVL, now it is a KCL. Then finally, with the same way you have to substitute, you are getting AIF equation. Then calculation of input impedance. So this is a constant formula, we already know this one, and ROF is to be constant. Here RIF will be equal to VI by IS. Same way we have to solve. Okay. Then finally end with the current equivalent diagram. The next thing is analysis of transconductance amplifier. So here I am using the word AGM. AGM is called transconductance, I naught by VI, and AGMF is nothing but transconductance with feedback. So both are series connection. So it is a series, and here it is series connection. So three steps: calculation of gain. We have three steps I have to write, and then finally have to end with this formula. Yeah. Then calculation of input impedance. Same way, Ri will be equal to Vi by Ia, this formula, and ROF will be equal to V naught by I naught. Both are constant. I have to disturb the remaining two things formula. Just now we got the equation of Vs. Just substitute there. You are getting this equation. Then calculation of output impedance. Same way, output is a current, so disturb the denominator. Get the equation. Just substitute, and you are getting that answers. Finally, you have to draw the equivalent diagram. And the last amplifier name is analysis of trans resistance amplifier. So voltage ARM, I am representing the word called ARM, V naught by II. It is called voltage shunt, otherwise called shunt amplifier. So both the connections will be the shunt connection. Then as usual, three steps: calculation of gain. Then you are getting the formula ARMF will be equal to ARM by 1 plus A beta into ARM. Then calculation of input impedance. Calculation of this impedance can be written by Ri will be the same formula. RIF will be equal to Vi by Is. So you are getting the formula RIF will be equal to Ri divided by 1 plus beta into ARM. And calculation of output impedance, same way. Our output is your voltage, so disturb the numerator term. And we are getting the equation of ROF will be equal to R naught into 1 plus ARM into beta. Finally, have to draw the ideal feedback trans resistance amplifier. So this is your summary of the four amplifiers. So I'm having four amplifiers. One is voltage amplifier, current amplifier, transconductance, and trans resistance. The first row indicates the names of that amplifier. The second row indicates the gain, final answer of the gain. Third and fourth is the gain of the input impedance as well as the output impedance. Thank you, students.